This is a physics problem in which we will solve for average velocity, change in velocity, and initial velocity. Difficulty is between medium and hard. This problem also deals with algebraic concepts. Okay, so we are given this graph and we are told to find our average velocity, change in velocity, and initial velocity from this information. Okay, so the scenario is that an arrow is shot upwards. It travels in the y direction a total of 5 meters and hits its target. Okay, and you can see here the time and the distance, right? Or the change in position. Okay, so the first thing that we're going to do is we're going to write down all the information that's given to us. Okay, then we're going to write down what we want to solve for and see if we can see anything that we can use from this. So we have here our change in the y position is 5 meters. Our time duration is 0.8 seconds. We are asked to solve for average velocity, change in velocity, and initial velocity. Okay, so our average velocity is given by two equations, right? We have final plus initial divided by 2, or we have our displacement divided by our time duration. Okay, so since we don't know our initial or our final velocity, we're going to use our displacement equation, okay, for average velocity. So it has an initial velocity and it strikes its target with a positive velocity, okay? So it's still going upwards as it strikes its target. So our final velocity is not 0. If that target wasn't there, the arrow would still be going upwards. Using our displacement equation for average velocity, we plug in our values and we find that our average velocity is equal to 6.3 meters per second. Okay? Now it wants to know our change in velocity. Okay? So change in velocity is equal to final velocity minus initial velocity. Now we have our final velocity equation, which is equal to final velocity is equal to initial plus AT, right? Reordering that to get V1 minus VO is equal to AT, right? So remember, change in velocity is equal to V1 minus VO, okay? So now we can write our change in velocity is equal to acceleration times time, okay? And our acceleration is the acceleration due to gravity. Now this makes sense, right? Because it's going to have an initial velocity and a final velocity. We don't know what they are, but we know that the only thing that's changing this velocity is the acceleration due to gravity as it travels from its initial spot to its final spot. Plugging in the values for acceleration and time, we have the following. Using a calculator, okay, we end up with negative 7.8 meters per second, okay, taking the two significant figures. Now we're going to solve for our initial velocity, okay? Now this part's going to get a little tricky because we don't know our final velocity and we don't know our initial velocity, right? But we do know our average velocity, okay? And we do know our distance and we know our time duration. So rearranging average velocity, okay, to have our distance equation, we get average velocity times time duration, right, is equal to our displacement. So rewriting average velocity in expanded form, we get that, okay? Now, remember, we also know that our final velocity is equal to our initial velocity plus AT, okay? Plugging in final velocity into this equation, we get this new equation, okay? So we have initial velocity plus AT plus initial velocity again, divided by 2, right, times delta t, our time duration, is equal to our displacement in the y. Okay, now reordering this to get delta y over delta t and simplifying within the parentheses, we have this equation, okay? Now, all of these values are known except for initial velocity. So we can now solve this equation for initial velocity, okay? So reordering this, right, multiplying both sides by 2, we get that. Then minusing by AT, we are left with this, okay? Now all we're going to do is we're going to divide by 2, okay? The 2's going to cancel, and we're going to divide this whole side by 2, right? And that's going to give us initial velocity, okay? Plugging that into a calculator, we find that our initial velocity is equal to 10 meters per second, okay? So now, as a check, if you wanted to, you write down your average velocity equation equal to displacement, right? You have v1 plus v0 over 2, right, times time is equal to delta y. Okay, now you might say we don't know our final velocity, but we do know our final velocity. Remember, final velocity is equal to initial velocity plus at. Now we have our initial velocity, we have our final velocity, we have our time. So you can solve for final and initial velocity, divide it by 2, multiply it by our time duration, and see if it comes out to our displacement in the y direction. It does. I've already done that, but it's just a way for you to check your answer and see if it makes sense. Okay? All right. Thank you for watching. If you like it, give it a thumbs up. If you have any questions, feel free to leave a comment.